Hello and welcome. I am Professor Joyce. Some of you may not have heard my voice as of yet. After reading through your posts this week, I've decided to create this video. I will say this is like my 12th attempt to do it because Kaltura kept locking up and not behaving well, and I'm pretty sure that the last time it failed was because of a Kaltura problem as well. Right now I'm using OBS, so we'll see if we can get through this. I'm going to try to get through this in like 20 to 30 minutes, but I did kind of want to go over and cover some subjects. In a large network with other people and even some households, you can't just start unplugging and rebooting equipment because it takes out the entire network. Instead of fixing one, you now just broke 300 plus, 1,000 plus users, the server equipment needing to communicate outgoing, any voice over IP you have going on, your phone systems and such, and any meetings which were in process via like Zoom, whatever video conferencing software you have, Polycom. If you want to hear people scream, do an unplanned reboot of any equipment in the middle of the day of a busy office. That is what I call a ballistic measure, and for most corporations, that's not an option. So, for the purposes of this network management class, you're supposed to have synthesized the concepts of how to troubleshoot small issues like network connectivity before calling your ISP. That's your job. You're supposed to know, hey, let's narrow down the problem to what it is, and gain as much information as possible in the least intrusive way. Okay? So throughout weeks 1 and 5, and this is information that has been covered in weeks 1 through 5 and possibly 6. I haven't gone through 6 yet. Well, I started reading it, but I tried doing this video like starting on Wednesday. So if the problem with the system is possibly malware or a virus, using a GUI to troubleshoot that is 1, time consuming, and 2, ineffective. GUIs and software can be affected by malware, which is why we go to the least intrusive and the best way to interrogate hardware, which is usually command lines. And the same actions you would take through clicking in multiple windows and drilling back down and going back inside an operating system GUI, you can have 4 windows up in a command line interface all in the same window and effectively do the same stuff and have all the information gathered. So if a ballistic move like rebooting network equipment and pulling wires and pulling cables were necessary, you would still have the information available to you. In addition to that, when you try to use the GUIs inside Microsoft, they like you to use their troubleshooting steps. And again, you know, if your GUI is infected with malware, your test results are not going to be accurate. And then you're also locked into that specific test area, and you have to keep reopening Windows. And then after the test, I don't know about you, but there's many times I've witnessed Windows saying nothing is wrong after running a troubleshooter, but you still can't connect. And then you fall down the 50-minute or 60-minute rabbit hole of unplugging, replugging, which in and of itself can create problems because you may have unplugged something which makes the situation worse for other users as well. And it could be something as simple as a network admin created a static route to route around a problem, and you didn't note it in the system, and all you got to do is delete that static route and rebuild the machine because it's infected by malware. So in situations like these, you need to start with the methods which will, 1, minimize impact to others, and again, gather the most information. In a home network, yes, you could end up resetting your router because your ISP pushed down a firmware update they didn't tell you about, and it forces you to have to do that. However, when you're working inside a large network, outages and updates are planned and you'll know about it. So that would kind of be one of those things where you would know if there was going to be a router update, and if you started seeing multiple issues, or Active Directory update, and if you started seeing multiple issues, you could possibly contribute it to those updates and then roll them back. But you wouldn't still want to go start pulling plugs and rolling back updates without confirming simple things on one machine. You know, if you had multiple complaints from your help desk and it's like, okay, we have the whole south wing down, then perhaps I would start with troubleshooting network wiring and routers. But if it's just one user on an entire huge network that can't access the internet, then you're going to start at that local source and start with the things that are the most probable, right? So if your network has been set up correctly, cables and hardware are hardly going to be the problem on a local computer unless someone's been messing around with them, like somebody, cleaning crew with a vacuum cleaner, accidentally pulled them out, or the weekend gremlins, as I call them, were playing around and moved some stuff, and just they were trying to work over the week and trying to get something done, and they didn't tell network people. Regardless, in each version of Windows, options are in different places, and where each of those options displays is different, and how much information you drill down into comes in a different area. And in order to demonstrate this, I'm going to use two different machines. You'll see a Windows 10 64-bit and a Windows 11 64-bit. As you can see, this one is encrypted because with Windows 11 it forced me to encrypt the machine in order to be able to use it with VM. It also forced me to ensure this trusted platform module. Kind of a pain, but we're going to deal with it. So I'm going to go ahead and log into this machine while that one is doing its own thing, so I can show you the different areas. Let this go ahead and log in, and I'll pause the video for brevity. Okay, so that's all booted up. Another thing I forgot to mention is that rather than searching for tools in a GUI, command line options are universal to all operating systems going back at least 8, 9, 10 generations. There are even some commands that work from Windows 3.1.1 today, so not all of the options will be there, like DNS and stuff like that, but you're going to be able to troubleshoot and 11 plus your Windows Server versions using these command lines. And then in addition to that, you have the PowerShell now in Windows 7, 8, 9, 10, 11. So all those options work all across these platforms as well, and they're always in the same spot. They are always within your command line terminal. So what I'm going to do is get these opened up. As I'm going to open up 3 administrator command lines. And a regular. Okay. Here is my regular. You will notice the difference on this regular one because it dumps you into the user's lab user directory within the written materials that I provided to guide me along and that I can upload. I will notate the difference of a command of when it needs to be run from an administrative command prompt and a regular command prompt by using the different notations that would be in general under Linux. And the reason I do that is because I'm not going to type this in or copy it in every time, and replacing it with, it's just second nature to me when I make notes for people to know that if I'm using a hashtag, that means it's going to be an administrative command line prompt because that's the way it is under Linux. However, if I'm using a $sign, that equates to a regular user or non-elevated privileges. This one would be considered, up here the administrator command prompt would be an elevated privilege, and this would be a simple user prompt. Okay, so let me just get these situated, and I'll begin stepping through the different things that I wanted to demonstrate to you. Okay, so the first thing I wanted to demonstrate, the first thing I want to demonstrate is where the difference between like even Windows 10 and Windows 11. Say I wanted to go in here and disable. I don't want to troubleshoot the problems because I don't want the machine getting involved, and I don't trust the GUI because it might be involved with malware. So I'm going to just simply disable the network if I wanted to this way. I would go into Open Internet Settings, right? And then I'd go down here to change adapter options. I'd find the adapter I wanted to deal with, and then I'd right-click on its options. But these options are only available to that one adapter, right? Over here in these command lines, any of these commands I run can be applied to any adapter at any time without me having to open up a whole bunch of other windows. On Windows 11, it's just as bad. I'm going to close out this window just to quit taking up memory. And over here on Windows 10, instead of having the same options that you had over there, you only have network and internet settings, but they don't take you to the same network internet settings, which is why you now have to click on this and settings. That's the recommended by the way. Then eventually you get into here, right? So then when you get into here, you have to open up you can click down and look at your network and internet connections. And then you go down here to advanced network settings. And then of course you have your two different network connections. But again, it is still only per connection. You don't have every option available in one window that you can sit there and compare to. I would have to click on this one, look at the settings, then click on that one, look at the settings, and then remember what I saw. Don't like it. It's just not functional for a network administrator to play that game. Okay, so I'm going to power this one off now because I just actually I'm going to suspend it in case I have to pull it back up again so it doesn't take that long to boot. And I'm going to go back over here to this window. Okay, so what I'd like to do here is show you, by remembering a few basic commands, which again will remain the same over different versions of Windows, you can launch these different prompts in separate windows, leave them up, and then go ahead and troubleshoot your network connections, right? So if I wanted to verify, like first thing I want to do is say, hey, you know what, I want to see if my network connection is enabled, because even though the GUI can play games with you by making it look like it's available, sometimes it's not because malware has interrupted that communication. So I'm going to do netshow. Netshow is what we call it, well, what I call it, because on Linux it's basically netshow. I'm going to do interface show interface, and that's going to provide me a list of the current network connections that are enabled and whether or not they're connected, whether it's dedicated, and it's going to give me the name, right? So that's great because from this one window right here, I can leave the information up to compare with other prompts that I'm going to deal with now. And what I'm going to do is I'm going to go further investigate that interface and see what's going on with the IP configuration. And again, I'm going to use my network interface command, my network administrator command prompt, because I get more information off that. Okay, so here we know this is our Ethernet connection that we see here, and there they all are, right? This is all of our connections. We see that we have a default gateway. We see that we have a DHCP server. We see we have a DNS server. So so far, we see they're all enabled. We see they're all good. However, in this interface, if I saw a problem, I'd go, you know what, let me just quickly disable and enable that interface, because what that's going to do, it's going to clear the IP address settings in case I initially had a problem and somebody got signed like another IP address that's conflicting with that one. So what I'm going to do is I'm just going to disable it. I'm going to verify that it's disabled. Show now that it's disabled, it's disconnected. And I'm going to come back over here to my IP config window. Meanwhile, this was the before, right? I'm going to run that IP config all command again just by pressing the up arrow. And lo and behold, it's totally gone now, right? So it's as if that network interface doesn't even exist. The other two exist, the desktop one right there, And this one exists, right? But that other one doesn't exist. So now I'm going to go ahead and re-enable that interface. Just by arrowing down and clicking in it and typing in enable. And then I'm going to verify that it's up again. It's now back up. And I'm going to go over here and I'm going to ipconfig all again. And now we once again see it. Okay. Notice that the IP address is still 128, which means that its IP address was valid and it was found to be able to do that. And then we can go about, we can now start verifying the internet connection properties. Also note, this is much faster than rebooting the machine and having to wait for things to come up, down, boot up, boot around, all the processes to load in the memory. We're just directly interacting with the machine, right? We're not even having to take the time to reboot the machine and play with cables yet, right? As of now, we know that we can get to the internet simply by pinging, let's say ping my email, my website address. Okay, we see we got a reply from that one. We'll ping Google. Okay, so we're able to get out now. So if that's as far as you had to go, you're good to go. But what if all of this weren't true and I wasn't able to get out? Like right now, I can demonstrate I can get out to the network over the internet. And we know these times are really quick too because you see the time in the TTLs. You don't even have to install any additional software. Okay, so let's just try to get to, let's say, Amazon. Yep, look at that. We're able to get out. So, if all of this was now not working, we would move on to other tools from the command line prompt like traceroute, DNS flush, route print, which is also the same thing as netstat-r, netsh, with firewall. Check the firewall connection, and then like ping the loopback address. So what I'm going to do is I'm going to change this VM over to a different, right now this device is in NAT mode, which allows the VM appliance, or hypervisor as it's called, to route the connection out to the internet. Okay, so what I'm going to do now is I'm going to break the router. I'm going to change it over to a different network, so I physically break the router. I'm going to change it to a custom one that I set up before I began this class, this instruction manual, and created the VMs. I'm going to change it over to my broken VM net that I created, which is set to host only, but not the same host only up there. This is set host only, like really broke. Not this VMnet host only is for when I want to communicate only with my laptop directly to the VM and lock it, or create it so that other computers just on that same VNet can only communicate amongst each other. This specific broken IP, I disabled DHCP on. So whereas this one will allow the hosts on that network to communicate, this one doesn't hand out any IP addresses, and there's none set statically. Okay, so now we're going to do the same thing we did over here before, right? We're going to show the status of the interface. Notice it's still enabled, it's connected, it's dedicated, right? But if I go over here and I do my ipconfig all, it's still going to show the same IP address. So what I want to do to force it to change the IP address is I want to disable the interface, then re-enable the interface. Well, before I re-enable it, I want to show you that it doesn't have, it once again updated itself to not show, right? So we now see just the two with the other one missing. Now I'm going to go back to this window and just hit enable. Now I'll go back over here, hit up, hit enter, and once again, here we are. I've got my interface up, and if I hit it a second time after it's done refreshing, you're gonna see an IP address of 169.168. Yeah. 169.254.239.146. Now, what we know from this 169.254.239.146 address is that means it's not getting an IP address. So, and we also see here that it has no default gateway. Well, computers use default gateway to get out to the equipment that assigns them IP addresses. And if it doesn't have a default gateway, we know it doesn't have an IP address. Now we got to start troubleshooting. And then again, this is where we move on to route tools like traceroute, DNS flush, route print, netstat, net show firewall, ping loopback. Okay, so the first thing here I want to do is I want to do a ping the loopback address first, right? The loopback address, as you know, is 127.0.0.1. This basically tests the, but I'm going to do it from the window down below, so I can leave that up. This tests the individual hardware inside the system. So if we get a response from this, that means that that hardware is working fine. And then from there, we move on. Like, we have working hardware. We have to figure out where this problem is. Let's figure it out now. So now that we've done that, as you learned in weeks 1 through 5, not that we don't already know that we can't get out to a domain, but if you did a trace route, google.com, you're not going to go anywhere. If you did a trace route or route print, or sorry, a ping, google.com, it's going to stop at the last place it's got. It's going to stop at your last address showing it can't get out. Couldn't find the host google.com. Why? Because it doesn't have a gateway address. It doesn't have the capability of DNS with this domain name system, which attaches an IP address to a domain name on the internet, right? Because we don't even have a valid DHCP IP address from the DHCP server at this point. So we already knew that, though, because that was about to happen. So now we want to see a netstat -R, but we have to do that from an administrator prompter. That's not going to work. So I'm going to bounce over here and do that. Well, we see here that the only interface for the gateways are 127.0.0.1, right? And all of our stuff is internal to us. So that means we definitely have a problem. There's nothing in here that's manually set. So we're good to go. But as you learned in that one lab a couple weeks ago, you could have something manually set in here that was a static route. And if it were in here, you could immediately just delete that route and then go ahead, disable your device, re-enable the device from up here, right? So you could delete the route, disable it, re-enable it, make sure you had a valid IP address, and try to go from there. Well, from here, we're actually going to go down to show firewall state. And I'm going to clear this real quick. Clear. Oh, no, that's okay. I'm going to do a net show. Now, firewalls. I personally don't enable firewalls on internal machines because often they interfere with communications between necessary update services ran on servers with Active Directory and update servers. And cause more problems than they're generally worth when you have devices already behind firewalls which have other layers like IDS, IPS, and content monitoring software. And if somebody is going to get a user to download crypto software or malware in general, it's not going to be caught by a firewall on a local machine anyway, because it's going to have a unique signature, because CryptKitties are all you have to do in order to avoid getting caught by those types of devices is just to change the file hash or the file signature, and they'll pass right by until it's analyzed by somebody months later and it's already involved the system. So if they're going to get to do something like that, your main thing with that is containing it. And if you have the appropriate policies in place anyway, that's not going to work, because your Active Directory is going to be able to control the file restrictions of a file and the manipulation of a file. And as long as a user doesn't have full control of it and the entire share it's on, they're not going to be able to crypto do anything. And they're definitely not going to be able to install malware on the machine because you're not going to have them being administrators of their machine. They're going to be very limited in the actions they can take. Most of the controls within their control panel that you or I, as a regular user on a desktop, are not going to be there. They're probably not even going to be able to install their own printers, and all that's going to be pushed down by Active Directory upon logon each time. So from here, I would work on looking at the firewall state just to make sure somebody didn't re-enable it. Also had that happen with updates, although WSUS should, on server level, should control that and not allow it. Okay, now you'll see that it says no ports are currently open on all network interfaces, but it does show our firewall is disabled as well. So here we can see it. We see that it's disabled. We don't have to worry about it. But if it were enabled, we would disable it, disable the port up here by running this command, re-enable it, test over here to see if we finally got a valid IP address, and then try to ping things, right? So we just keep repeating the process in these 4 windows. Try this, disable, enable, look at this, repeat this process. Okay, so if our system were really broke, and at this point, if you've disabled your firewall and you tested everything, right? And the system were really broke, it's also possible with that 169 address that hardware, cables, down the HCP server, but if your other users are on the network, you don't want to kick them off and break them just to verify one user. So what you could typically do is notate all the information here. Notice we have the MAC address of this machine, of this device already, right? So from this point, go make sure that this MAC address is not being filtered by any VLAN that you may have instituted or any subnetting that you have going on at the server, and make sure they're plugged in still to where they're supposed to be. Look at the lights on the back of the computer before you even go do that. Make sure those are on and operational. Even though we verified the hardware itself, it doesn't mean that somebody didn't swap out a network cable because like I said, the gremlins over the weekend, or somebody decided they needed a brand new network cable at home, so we'll swap out our office one because we really don't want to go buy one and we need to work from home. I've had that happen. But anyway, that's where you go from. You don't automatically start down the hardware area because you're going to assume that the hardware is probably the least vulnerable in the setup. It could be, these are easier things to check than pulling out hardware and then having to plug it back in and test individual stuff. But from this point, where you can see your firewall's disabled, you still can't communicate, you're still getting an address that is 169 capabilities, then we'd start looking at the cables, a down DHCP server, see if you've been sandboxed by something on your network. And by that I mean put in a timeout because something was sensed that shouldn't have been there. And that's when you'll need to have a network administrator that is working on the system that knows where to go to look for that. See if your machine swapped out its cable on the port switch. You learned last week that you could be assigned to multiple VLANs. Well, sometimes somebody accidentally swaps you out not knowing the network configuration because they're trying to troubleshoot somebody else and then they forget to put it back. That again is why we don't begin pulling, LAN cables or patch cables on the switches and stuff. Okay, go to Active Directory. See if the machine is authorized. Sometimes Active Directory can cough, hiccup, not like the machine, and keep it in a bad zone for Active Directory. Maybe there was somebody getting fired that day. It may even be the person who called with the problem, and they told IT to take them offline, but typically IT would know, maybe not the lower people that are troubleshooting at the lower end of the network scale, but the IT director would know. So at this point I would go to the IT director, but you still want to go to the computer to make sure that you're doing all this, because you don't want the person to know they're getting fired either. So you still want to go through the troubleshooting steps. And if you do find out they're getting fired, please do not mention it to them. That tends to not, they tend to not do that well. Okay, so now we've covered all the 169s and the 168s and the 198s. Note, like I said, you already know your MAC address over here, right? You already know your IP address scheme that you're supposed to be on. You already know what you're getting. But keep in mind that during all this information gathering that you've done, you didn't pull anything's power, you didn't pull any cables, and you don't have to deal with a bunch of people calling and screaming because you took them out and they weren't able to do their job. Okay, hope this has been welcome. Hope this has been informative. Thank you, and have a nice day.